Hello everyone, this is Bradley. So today this is a continuation from the last tutorial in which we've talked about a technique called UV sampling in geometrynodes 3.4. Starting from this tutorial, we're going to move on for some practical animation instead of just talking about fundamentals. Also knowing that starting from this tutorial, I'm going to use the presets which you can download for free from the link in the description. The entire point is that I'm not going to repeat whatever I've said in the past. Like in the last tutorial, I've mentioned this entire group of nodes are going to be the standard of UV sampling. So I'm not going to build this setup every time in the future. Rather, I'm just going to use a preset, which is called UV Deformer. I choose this name because it seems like everyone else is calling this name in Cinema 4D or Houdini. So I decided to just make the name consistent in the industry. So at first, let's firstly discuss the basic usage of this UV deformer. Let's wrap up what we have done in the last time. So originally I have this kind of a Suzanne monkey head, and I'm basically just deforming this Suzanne monkey based on the plane by sampling its UV surface with the position of our Suzanne monkey. It's kind of a little bit complicated to discuss. It doesn't really matter if you do not really understand what we're discussing, because either way we're going to minimize this entire workflow using the presets. So to use this UV deformer, because it already includes a set position inside, so you basically just put the UV deformer and instantaneously we lose our Suzanne monkey. The reason is that we need to input a source in order to deform or set the position according to the plane. So we need a plane. So previously we have this object info, so you just input a plane. But now we still didn't recover our Suzanne monkey because instead of the default UV map, in the last tutorial, I've renamed the UV map into the UV. So instead of UV map, let's just type UV. Then instantaneously we recovered the Suzanne monkey and our circles. Okay. Here you can actually find there is some similarity between this sample UV surface and UV deformer, in which the mesh is the source, source UV map is the source, and the name the attribute, and the the sample UV is the sample UV. So basically that's it. And the normal factor, as we've discussed in the last tutorial, is basically the kind of all this kind of calculation and whatever. But by using these presets, we no longer need all these kind of nodes. So we minimize the node tree and speed up the workflow. And this node will be used every time from now on once we are going to work with this kind of sample UV technique. As we already know the basic usage of this node, let's move on to do some cost simulation. So first, let's start with a new Suzanne monkey. And I'm going to add a collision surface. And then I'm going to add a plane. This is going to be our cloth. So just increase the size and add some subdivision. I'm going to add that simple. And I'm going to disable this optimal display so that in wireframe mode, we can see the amount of subdivision more clearly. Okay. And then I'm going to add a cloth simulation. Personally speaking, I have this sync into the sync to audio, but it should be play every frame in order to make the simulation work better. Okay, so now if I try to play this animation, let's take that to 1000. Then we can see our plane is actually dropping and colliding with our Suzanne head. Okay. So this is just a simulation, and we can bake this simulation. Let's just take that back to 100, and we can bake this simulation within the cloth. I'm not going to do all these kind of settings. You can do that in your free time, but I'm just going to bake that at 100. So let's just bake it. So now I've finished the baking. Let's just play this animation. Because everything is already being baked, so it's very smooth. There's no additional needs of calculation, but it's kind of very boring, just the kind of a class simulation. There's no any kind of pattern stuff. So here, let's rename that as a class, and we are going to do the geometry deformation with it. So let's start with a new object. Let's name that as a deformer, and add a new geometry node tree. Within this node tree, I'm firstly going to do a very stupid pattern. Let's just add a grid, and we can hide other objects and view the wireframe, because I want to know the amount of subdivision I have. Maybe add the size into 3:3 so that we can see it more clearly. Okay, something like that, and let's take a match to curve and the bevel curve. So finally, we're creating this kind of web. Okay, we're creating this web structure. And then let's just take the UV deformer with our class. Let's take the class as a source. And I'm going to use the relative so that we can see our grid has been mapped onto this class. So now if I go back to the timeline, we can see it's flying on the sky. And we can take our Suzanne monkey below. And by playing this animation, we can see this web is actually falling onto our Suzanne monkey. So this is a basic idea. So this is just a basic example. We're going to move on with some more complicated example than just the kind of web. So here, right now, we do not need all this kind of Claus and Suzanne. We're going to create a pattern, a knitted pattern, which I've discussed in the past. So let's start with a curved linear. A curved linear is basically just a curved line node with resample, so that instead of just a start and end, I have the count in between, so that I can point instance with another curved linear to create a patterns. So here I'm going to switch XYZ into the 1, which means Y-axis. So on Y-axis, I'm instance a line on X-axis. So this is the pattern. I'm going to Control H to hide this instance on point. And then I'm going to realize the instance so that every curve can be different from each other with set position. So the core concept of a knitted pattern is basically sine function. So let's take a combine XYZ and let's take a sine function. Sine function is basically just a sine function that you can find in math nodes. It's very simple, but in order to make it operate or change the parameters, for example, frequency, phase, and amplitude, you have to have a lot of other math nodes, like multiply for frequency, multiply for amplitude, and there's another add node for the phase, and so on and so forth. Okay. It's a lot of math nodes. That's why I made a sine function in order to replace all this kind of math node. Okay. So we're going to use the kind of spline length in order to drive the value. So let's take a Y. Let's increase the frequency. You can see it does not really work very well. The spline length is actually a single value, so let's actually take a spline parameter. Yes, now it started to work. So every point has a different length. So maybe this point is 1 meter, that point is 2 meters. Okay. And then let's increase the count so that it smooths out edges, decrease the amplitude to make it look better. Let's take a value to control the frequency because we're going to duplicate this sine function. So here, let's increase the count and increase the frequency. We have so many waves. Okay. Going up and down. Next, what I'm going to do is, knowing that sine function, we have a peak 1, peak 2. And for each one peak, I'm going to make a new deformations on the x-axis. So let's duplicate this sine function and put that into the x-axis. So now you can see there is an immediate some kind of result, but I'm going to take a mass to multiply that by 2. And by taking this amplitude to negative region, then you can see we have this result. and you can try to tweak that so that they are interlacing to each other. But this is everything is on a plane. But I'm going to manipulate the z-axis so that they are moving up and down. So I'm going to duplicate the sine function again, and now plug in the sine function into the z-axis. So now we can see there's an up and down, up and down. As the frequency is the same, so every peak is up, another group of peak is down, they're unifying. But here what I would like to do is to, in order to make that interlacing each other, the phase of up and down should change. So at some point they should actually switch up and down relationship with this kind of phase. So in order to do that, I need to distinguish which curve is the first curve, which curve is the second curve, which curve is the third curve. To do that, there is a preset which is called the spline info, which is giving a spline index. It's very simple. So this is within inside that preset. You can see there's index and this interpolated domain on the spline domain. So it's giving an index for every spline. So here, let's take a modulo at 2. And then we can multiply that. Just multiply with a value and take the phase. And I do not know the correct mathematical values, and I also do not really worry about that. So let's just eyeballing it, and maybe like take that as a 3. Then you can see there's the up and down relationship already. I think this is good enough. You can definitely make it more accurate or something like that. But here I'm just going to bevel curve. So this is what we are having right now. And you can see this is a very nice interlacing patterns. Okay. And a last step is basically just to plug this setup into the geometry. And we can see it goes on to our initial plane of the cloud simulation. So it already flies on skies, and then it collides with the monkeys. And finally it folds, like the cloud simulation. Okay. There are several issues with this particular setup, like it has been stretched so that the z-axis is kind of being distorted. So what I recommend is to take the bevel curve as a last step, so it will not be deformed wrong. And you can see these kind of interlacing patterns. This is kind of very ugly right now because it's too large. You can increase the frequencies and change the parameters to make it looking good. But that's just the kind of parameter thing. As we have finished this knitted pattern, I'm going to group this combine XYZ with a Control J and a frame it. Let's rename that as a maybe knitted pattern. You can make this into a node group for sure. And I'm going to reuse the previous grid in order to introduce you another pattern, which is called a braid pattern. It usually happens in hair. Okay, and it's basically another sine function. Here I'm going to take several vector. One is curve tangent, and the other is curve normal, which is just called normal. Okay, and I'm going to make a cross product between them. So what's the tangent and then what's the normal? So if I have a curved circle and the direction facing outside is the normal, and the direction following the flow of this curved circle is the tangent. So what's the cross product? The cross product is when you have two vectors at 90 degrees. It's a little bit like a right-hand rule in physics. Cross product is giving a straight vector out of the plane. That's basically the idea. So here I'm going to take this cross product and scale that by a sine function, and give an add to make another scale with the normal. Okay. So basically I'm giving two directions. One is to deform at the cross product between the tangent and normal, and another is bending in the direction of normal, something like that. So, and let's take this into the offset. I'm going to take a sine function, and again we're going to drive that with the length of the spline parameter, sine function 1 and the sine function 2. And let's increase in the frequency. So take a value, link to sine function, and you increase that. Now you can see one is moving up and down, and the other is left and right. So let's decrease the amplitude because we don't need that high. 0.1, 0.1, something like that. So now it looks like this. Okay, so the braid pattern is basically an interlacing pattern of 3 splines, but now we only have 1 spline on each segment. So we're going to duplicate elements, but now we lose everything because it's actually duplicating the points. We need to duplicate the spline and set amount at 3. Right now, it looks like we still only have 10 splines, but the reason is that geometry are overlapping into each other. So essentially, these are actually 30 splines, with the 3 splines overlapping to each other at each place. Okay, so we are going to distinguish them, which means we again are going to use this spline info node to give each spline an index. Okay, and here I'm going to firstly take a modulo. So loop this index at 2 or probably 3. So I will have 0, 1, 2, 0, 1, 2, and 0, 1, 2 index for the spline within them. And let's take a math to put a multiply. This multiply number is just anything. Okay. So now if we increase this multiply number, we can actually see this kind of result immediately. And that's basically the idea. So let's just finish this entire setup by putting the face into the first sine wave as well. And in order to make it really interlacing the left and the right, we're going to add we need to multiply the frequency for our first sine wave. And you can see this kind of ugly pattern, but they start to interlace into each other. And to fix all the problems, we're going to use the relative phase instead of constant phase. So the difference between this constant and the relative phase is when you are doing a sine function, if you add outside the sine wave, it's basically the constant, and if you add inside the sine wave, then you are changing with the frequency, then it's the relative phase, which actually means that if you're increasing the frequency, then the factor will change. So you have to adjust manually. Since I do not really know the math to make it procedural, but I think it's just fine. And to better visualize the braid pattern, now it looks a little bit like DNA, but it's not a DNA. And let's increase the radius a little bit. Then you can see this is so-called a braid pattern. It's not a rope. It's a little bit more complicated than rope, in my opinion. But that's basically the idea. And you can group them together, just like we've done with the knitted pattern, like a Control J. And then you can have this braid pattern. And basically that's it. And finally, this is completely procedural. Then you just increase the count, making them overlapping to each other. They are not really connecting to each other, but it may look like so. Anyway, so if we play this animation, then you can see it falls down and collide with the Suzanne head, just like a kind of towel or cloth or whatever stuff. So everything is kind of procedural, except for the simulation part. But the rest is you can do whatever you want. You can increase the resolution, decrease the resolution. It's just nice. So I hope you enjoyed this tutorial. I hope you enjoyed this tutorial. I hope to see you next time. Bye bye.